Hello everybody, welcome to my video. First of all, I'd like to thank you for all your support, all your encouraging words. Thank you again. Today, I will talk about a physics problem. It's dynamics. So let's start. I have a table on which there is a mass. There is a mass, 12 kg, on the table. And between the tabletop and the mass, there is friction. There are two kinds of friction, static friction and kinetic friction. Static friction is when the mass is not moving. Kinetic friction is when the mass is moving. So what is this label? It's called coefficient of friction. And the definition of the coefficient of friction is friction coefficient is the ratio of the normal force and the friction force. So the ratio, the friction force of friction divided by the normal force. So the friction force is the coefficient of friction times the normal force. The ratio of force of friction to the normal force is called the coefficient of friction. So you cross multiply, the force of friction is mu, the coefficient of friction, times the normal force. What is normal force? Normal force is the force to support the mass by the table. In other words, the normal force is the force applied to the mass by the force. But why we call it normal? Why not just force? Because this force is perpendicular to the surface of the table. Okay, so once we understand this, we go on for this problem. There is a pulley here. A pulley is here, and this mass is tied by a rope over the pulley and tied to another mass. Let me draw that out. This mass is tied to this mass through a pulley, through a rope. Okay. And the floor is 2 meters. Floor is 2 meters below this mass. And this mass is 8 kg. Okay, that is a problem. What do we want to find? We want to find, first of all, we want to decide whether this will move. whether this mass will move this way and this going down, or they just stay there. The case stay there happens if the friction is too much, right? That we understand. So we need to find whether it moves or not. Let's suppose the two masses are not moving. So we will compare the force of friction and the force which pulls it, which one is bigger. If the friction force is bigger, it won't move. If the friction force is smaller, this will move to the right-hand side, and this will drop down. So let's find out that first. If everything is not moved, what is the force of the loop? This we call it tension. So what is the tension if nothing moves? Okay. If this is not moving, then the force of gravity and the tension should balance each other. Balance means they equal to each other. Therefore, if it's not moving, the tension is equal to the force of gravity. So tension T is equal to the force of gravity. The force of gravity is mass times acceleration. Now this acceleration is acceleration due to gravity. The magnitude is 9.8. Okay. So it's mg. If it's not moving, all right, okay. So let's see that. M is 8, G is 9.8. It is a constant. So this is the tension. Let me see, I have the numerical value there, 78.4. So this is the tension. The unit of tension is force. Force unit is Newton. Is Newton. Now, this tension is here. But this is one loop. It's not two loops connected together. It's just one loop. So the tension here is the same as the tension here. So the tension on this portion of the rope pulls the mass. Then we compare whether this force is smaller than friction or larger than friction. So let's look at this mass. What is the force of friction? So force of friction is this. This is the formula. Because we are considering nothing moves, therefore this mu is the static coefficient of friction. So let's compare that. So the force of friction, we use the value of static friction. And this value is given by the question. Okay, 0.6, 0.5. So I use static coefficient of friction, 0.6 times normal force. As I said, the normal force is the force applied to the mass by the table, which is the force to support the mass. So this force is, of course, equal and opposite to the force of gravity. So this force, this normal force, is numerically equal to the force of gravity, numerically, okay? So it's mass times G. G is again 9.8. So coefficient of friction times the force of gravity of this mass, which is m times g. So this force is, I worked it out, is 70.56. Okay, so this is 70.56 Newton. So let's compare the friction force with the tension. And we see that the friction force is smaller than the tension. Tension is a force which pulls the 12 kg mass. So tension is larger than the friction. Therefore, the two masses will move. One move to the right-hand side, one just dropping down. Okay. So once we decide it moves, we continue our work. The question is to find what is the tension in the force. And when this drops to the ground, it hits the ground. With what velocity it hits the ground. So you need to find these quantities. So let's continue now. Then what we need is free body diagram. You have two bodies, so you have two free body diagram. Okay, let's draw that. This is the free body diagram for the 12 kg mass. There is a tension force pulling this mass to the right-hand side. There is force of gravity going down, and at the bottom of the mass, of course, it's above the surface of the table. Between the table and the mass, there is a friction force. The friction force is pointing to the left-hand side. This is the free body diagram. Because we have decided it moves to the right-hand side, therefore there is acceleration. The acceleration is to the right-hand side. Now there is a second body, 8 kilogram, and we need another free body diagram. There is force of gravity, the mass times 9.8. And there is the tension. The tension is pulling this mass up. They are not balanced because we already decided they will move. The 8 kg will move down. So there is acceleration down A. That is the acceleration. We must know that this tension and this tension are the same tension. Why? Why these two tensions are the same? Because it's the same loop. It's not two different loops. It's the same loop, just going over the pulley. So it's the same loop. Of course, the two tensions are the same. How about the acceleration? The acceleration for the 8 kg and the acceleration for the 12 kg, are they different or are they the same? The answer is they are the same, because the two masses are tied by one loop. So whatever the 8 kg moves, the 12 kg moves with the same velocity, same acceleration. What is different is that the direction of motion is different. So one acceleration is to the right hand side, another acceleration is going down. But they are the same. What I mean is they have the same magnitudes. All right, understanding this, then we can go ahead. We write Newton's second law, force equals ma. Allow me to erase this part, because this part is just to decide whether it moves or not. We now need Newton's second law to continue our calculation. All right, so for the 12 kg mass, I can write in Newton's law, net force equals mass times acceleration. What is a net force? I have two forces. Well, you can say you have three forces. But the acceleration is to the right-hand side. So the Newton's law is only along the x-axis or horizontal. Acceleration is horizontal. I only need second law in the horizontal direction. Remember, Newton's law is a vector equation. Force is a vector. Acceleration is a vector, but mass is not a vector. The direction of force, I should say the direction of the net force is the direction of the acceleration. And you only want the horizontal net force. So this has nothing to do with the Newton's law here, all right? So let's write force equals ma now. What is the net force in the horizontal direction? Because it moves to the right-hand side, therefore this force must be larger than that. Therefore the net force is T minus friction force. T minus F of friction equals ma. I am talking about 12 kg mass. So let's concentrate on 12 kg mass, okay? So it's T minus friction force is, it's moving, right? So 0.5, that is mu, times normal force. The normal force is mg. So this is mass, this is g. So this minus friction force, coefficient of friction, force of gravity. Then what is this equal to? I need some space here. equal to MA. M is 12. A is unknown. So this is for 12 kg mass. Newton's law. Now for the 8 kg mass, I have Newton's law. Force equals ma. A is down. Therefore, the net force is now I write Newton's law for 8 kg free body diagram. So net force is net force is this force minus that force, because I want net force downward because acceleration is downward. So this minus that. So this is mg. mg minus t equals a. That is mass. Okay. I have two equations from Newton's second law. Look at this. Two equations here. We noticed this t is positive, this t is negative. If I add these two equations, the two t's cancel each other. What is left is just acceleration. So let's add these two equations. Then I have this minus that. T cancels, equals this plus that. So this is a trick. You add these two equations, t cancels. All right, so let's do that now. Left side plus left side cancels the t. Right side plus right side, 12a plus 8a. Okay. This is just just 20a. Look, in this equation, a is the only unknown. Therefore, you can find a. Okay, let's do that. And I found a. Let's see. Okay. Is it all right if I do not write those numbers, just find a? Should be all right, right? I guess. Okay, so a is 0.98. You work out the left-hand side, divide the left-hand side by 20, you get a, and the result is this. And the unit is meter per second squared. Now the rest can be done by using the value of a. You put the value of a into either this equation or that equation, you can find the t. And t is what we want to find. Let me label that. We want to find t is what? So this is how you find the t. We find the a first, and then you can substitute the a into either equation and find the t. Let's see now. This is what you do next. So suppose I put the a into here, then 8 suppose I use this equation. It doesn't matter this or that. It doesn't matter. You put it in and you can find the t. So the result is t is equal to the result is t equals that. The question also wants us to find with what velocity this 8 kg hits the ground. So I need some space. Let me erase this part now. Before I solve for the velocity, let me review kinematics. Remember, if you go to the textbook says there are big 5. There are 5 kinematics equations. My experience, everybody has different experiences. My experience is that don't spend effort to remember 5 equations. Just remember 3 of them. That's enough to solve all the kinematics problem. 3 is enough. The other 2 depends on the 3. You can derive it. But why do you want to spend your effort to remember all 3? So let's, all 5. Let's do 3. What's 3? I recommend this. These are the 3 equations I recommend for all kinematics equations, kinematics problems, I mean. In this case, I want to find v. This is the final velocity, which is called v2, because this moves from here to here. The velocity here is v1. The velocity here is to v2. We want to find the velocity when it hits the ground, so we want to find the v2. What do we know? We know the distance moved is 2 meters. So I know d, I know v1, which is 0 because it starts from rest. So v1 is 0, d is 2. What is v2? Go to this. I don't want t. T is not given. What is the time it takes from here to here? What is the time? You don't know. If you want, you have to find it. But because you don't know, you don't want this equation. You don't know t, so you don't want this. v1 is 0. It starts from rest. I know d is 2. A is here. So use this. Clear? Use 3 kinematics equations and find out what you do not want and what you want. So let's do that. This is 0, so you don't want it. So it's 2. A is 0.98. D is 2. Therefore, and you do it, so take square root, and you need a calculator. So the answer is nearly 2. So I rounded it. Is 2 meters per second. One remark. If you do mathematics, you know that you take square root, you need plus minus. But this is physics. Remember, physics, because you need to see what is reasonable. Can you have a negative velocity? No, you don't need plus minus. It's just 2. So you have every answer here. Okay, I hope you follow. If you really don't follow, maybe you can find my telephone number and give me a message. Yeah. Okay, that's all for today. Thank you for watching, and I'll see you next lesson. Goodbye.